Welcome to my talk, which apparently my naming joke was also simultaneously thought of by Lawrence Moroney if you went to his talk 2 hours ago. But it's a clever one. The goal today is to walk through everything you need to understand in order to be able to understand how Job Scheduler works, because if you can know how to choose between different options with building a background task, you'll be able to just build a better app, which will be really great. But Job Scheduler is really scary, and nobody ever wants to talk about it, because if you bring it up and somebody starts talking to you, you probably won't understand what they're talking about, and that's hard. So we're going to go through all of it, and by the end of this, you're going to walk out of here like ready to name drop Job Scheduler and like just really ramp it and like advocate for it. So it'll be great. Why you should listen to me. I am Joanna Smith. This is a copy of my bio off the website. You can read that or not. But specifically, the things I've done with Android, I co-founded the Android Development Patterns Initiative. And so we have a lot of videos, me and Ian Lake, he's right there. You probably just watched his talk. We made the videos, and we have a weekly pro tip series of written content, and we have a lot more ideas coming over the next year where we're trying to identify, bust bad behavior and teach best practices, because we have a lot of developer outreach on how Android works and how APIs work and really like how you can implement, but we don't have anyone telling you when to implement or what to choose or what the options are, or like if you have 13 different paths, which one's going to be best for your app. And so we're trying to tackle that problem. Watch our videos, let us know how well we're doing. And then also we created the second course in our Udacity Android Nano degree. So if you're trying to like expand your skills or just brush up on something you haven't seen before, that's a really great resource. All of those course materials are available online for free, but if you like enroll in the class and pay the fee, you also get like instructor guidance, so it's pretty cool. And then this is just like a fun fact I like to throw out there. I started learning Android actually in February of 2014, so I'm very new to this game compared to a lot of people, and I like to bring that up because it can seem really intimidating when you're learning something new and you're trying to get into it, and everyone's talking about all these words that you don't understand, and they're reminiscing back to like how gingerbread was so ugly, and you're like, I don't even think I ever had a gingerbread phone. Like, I don't know how to participate in this conversation, and it's intimidating, and this is a hard problem to solve. And I just want everyone to know, like, I did this lesson 2 years ago, and I'm giving a talk to you guys as if I'm an expert. Like, you can really learn a lot really fast if you just kind of like push yourself and try. So that being said, let's try background services. The goal here is we want to do a bunch of work off of our main thread. And because that main thread is also called the UI thread for a very good reason, meaning that it controls everything that you can see on the device. So if something starts to go wrong and you're still on your UI thread, your user is just going to see this hideous thing. Don't be this. It's ugly. I couldn't even find a good picture of it because nobody wants to screenshot it. It's such a horrifying sight, right? And I didn't know how to make one. So no, if you show this to your user, if this comes up, your user is immediately giving up on you. They're leaving the app, they're not trying again, they're not gonna try to refresh. Most likely they won't open your app again, and they'll probably even uninstall you. Like, this is a death warrant, and you don't wanna see this. But the thing is, that's what users see. What it actually means is that your app is working really hard, and it just needs a minute. And that's what's really frustrating, because the developer perspective here is that, you're trying to do work and you just forgot something, but the user perspective is you're the worst ever and I hate you. So we're going to move on, and we're going to avoid this by moving something off the main thread. Work that's going to hang is going to make us miss our frame rate, and we don't want to do that. So we're going to just shift it away, and then it can resync with a later activity when it's time to actually update it, instead of trying to like pause the current activity and wait for it. Okay, so that's our goal. So we don't want to miss our frame rate, because if we miss that, Colt McCandless will just magically appear and start hating on you. So the question is, where do we start? And when I say background work, all of you are probably thinking, oh good, async task. And that's not correct. An async task is actually tied to your activity lifecycle, and that can have its own advantages and disadvantages. So I'm going to focus on work that is entirely off the main thread, and async task has its place, and you can read all about it on your own. So let's start with services. What's a service? Well, it's complex. They're hard. They have a lot of pieces you have to manage. Services run in the background. They're fully apart from any app activity or fragment, but that means that it can keep running even when your app isn't, which is actually pretty fantastic. But because of this, that means that services can't affect your UI. So, if you actually want to show a progress dialog because what you're doing is in response to a user-initiated action, you probably do want your async task. That's a really great way to do it. But if you're kicking off some sort of activity that only needs to report back when it's done, and maybe update the UI then, a service is going to be great because it can send that information back through other avenues later on. But yeah, you can't update the UI while you're in a service. So in your results, you have to pass it. Services are great for things like syncing with your server. This is something that's not usually user initiated, but you want to like back up all those photos they've been taking in your app. Like that's really important, but that doesn't have to happen exactly at that moment. That could happen when the phone is put down or is idle, or just whenever there's a chance and the radio is already on. The other thing is that services have to manage their own life cycle, and that can be kind of intimidating. Because you have to first figure out which methods to override, and then how to override them, and then what you want to leave alone, and then how you call it, and then it's just a lot, which goes back to my point that services are complex. So that's why we're going to talk about intent service, which does all this work for you. Like, how nice is that? So an intent service is a much easier implementation because it will handle all of its own life cycle. You don't have to worry about starting it or binding it or letting it go or destroying it. Like it does all of that for you. It's already written. You can focus on what matters, and that's the background work and not how you get into or out of your background task. The trade-off here with an intent service instead of the other one is that an intent service can only handle one thing at a time. All requests will happen sequentially. So if your app is designed with multiple requests that might come in and all need to execute at the same time, you're going to have to read the documentation on how services work. Sorry. Okay, so how do we create an intent service? First step is you have to make a class for your service. And to do that, you need to declare it in your manifest. You have to say that this is going to be here. Like, this actually exists, and I'm going to use it. And then, of course, some of you may know exported is this variable that says you can restrict to your app, the service to only being accessed by your app, which is what false means. Or if you say to true, other apps may be able to interact with your service and set it off, which is sometimes really valuable. You can also declare multiple services. You can have 13 of them, and each one is a very targeted service. Like definitely a real service could be definitely a real share service, and you could have definitely a real backup service, and everyone could have its own specified task, which makes code maintenance really easy and also means it's a lot easier to track what's going on and what things are going wrong. But most importantly, your service needs to extend from intent service. So here you've got your class, and the only method you have to implement or override by default is onHandleIntent. You can actually just ignore all the other ones. That's that whole life cycle being handled for you thing, which is pretty fantastic. So onHandleIntent, this is where all of your work is going to happen. Imagine that. So maybe this is where you're going to open a network connection or send data to your server and then clean up that connection. That would be pretty great, cleaning up your network connections. Or maybe you want to write to the SD card. All of this kind of stuff is definitely not supposed to affect your UI, but maybe you'll send the message updated and change something to green. But all of the data you might need, you can put into that intent as an extra, pass it along, and then use that to maybe kick off a notification or kick off the work that you need to do. Anything that's really relevant. A service is pretty versatile. So once you've got it written, you need to invoke it, and this happens from usually an activity. And to do that, you need to create the intent, fill it with something, and then pass it. And passing it is great. You just call start service. It's actually that easy. Okay, start it, I'm ready. Like I said, intent service manages its own life cycle. You don't have to start it, bind it, all that other stuff. You just call start service with the intent and you're done. That's actually all there is to it. And then with all of the data you pass along, then your service might be able to actually use that same kind of intent to report back. So give it enough information to know what its job is and if a response is necessary too. Okay, so you know that you can use it with calling start service, but the question is when to call start service, and my advice is usually from a broadcast receiver, because these are really great ways of waiting for a signal that something needs to happen. Whenever anything actually that needs to happen. So a broadcast receiver's job is to respond to an announcement, and that comes in the form of yet another intent. These are magical little things of I'd like to do this with these constraints. So an intent is a common trigger for kicking off background work, which is great because a broadcast receiver doesn't actually bring your app into the foreground. It can kick off a service that may or may not affect foreground work, but the broadcast receiver itself opens, runs on receive, and then triggers whatever's in that, and then stays all in the background. So you're still protecting your main thread, which is our goal here. Okay, so broadcast receivers can actually interact with several different sources. A local broadcast will come from within your own app. And this is a sign that maybe it's time to sync, or it's when you kick off the service, or maybe it's actually the intent service reporting back about how the job went, or this failed, or that's not a real URI. App broadcasts can also come from other apps on the device, which is really great when you're trying to take advantage of functionality that you don't want to build but somebody else offers, or you want to offer functionality to other developers so that you actually get users using a lot of different really great things. So you don't have to keep rebuilding, picture taking every time, right, or storage or something like that. System broadcasts are really important. They carry status information, things like something being plugged in or like a signal that's changing, something you might be subscribed to. So if you really care about, your app only runs when plugged in because maybe you're a sleep tracker and you don't want it to fall asleep like while the user's also asleep, that's the kind of thing you would like wait for the signal on this, and then if it came unplugged, you'd get a broadcast that is unplugged, and that might change your behavior. You might like only stop tracking data to that point. And finally, you can use them for server messages, like downstream messages. GCM actually has its own dedicated broadcast receiver system, which I'll tell you about. Downstream messages are a great way for your server to indicate that something needs to happen now, which the app might not be able to give a signal on, right? And so any kind of message, so basically broadcast receivers are the best thing ever because any kind of message can come through, and then you can react accordingly and maybe start off any kind of different service. And just like a service, you can register multiple receivers. So let's talk about how to do that. With an intent service, it's the same thing. You have to create the actual class and then declare it, your receiver in your manifest. It looks roughly the same. But the meat of everything here is going to live in this method called onReceive. It's really the only thing you have to override with a broadcast receiver. And this will do all of your intent processing. Like you get the intent that comes through, and any extras might indicate what kind of work you're doing here. Maybe your broadcast receiver does double duty, maybe it doesn't, but this will like help you do any kind of processing and kicking off your service. The thing about a broadcast receiver is that it only lives for the duration of this on-receive call, which is like milliseconds. So you can't do your core of your background work in here. You need to offload that to prevent any further hanging. Because otherwise, as soon as this call completes, it dies. So like also, if you have like a helper method, like you just don't really have a chance here. Okay, so you also have to register your broadcast receiver. Like you have to say which intents you're interested in, so you don't just get everything. Like that would be a nightmare, like just constant information coming in. And I recommend looking into what's called Local Broadcast Manager, because if you're really just using broadcast within your own app as a signal to and from services, this is a great tool. You can also include like an intent filter, be like, I want this intent with these kinds of parameters and stuff. So let's just set up everything for a number of situations, and I think it's pretty great. So check the docs on that, because we're going to move on to what's called a wakeful broadcast receiver. I told you that onReceive only lasts, like your app is only brought to life for like the duration of onReceive, which means that there's a chance that between onReceive and start service, like onReceive wraps and your service hasn't started yet, there's a chance that the system might take away your CPU time in between that. So if you need to guarantee that your service runs the moment that onReceive ends, you want to acquire a wake lock, and you want to hold that wake lock until your service has a chance to run. But wake locks are hard, and you shouldn't have to waste your time on that because we did it for you. We created the Wakeful Broadcast Receiver, which manages its own wake lock and still guarantees that your service will run immediately after onReceive. So again, look at all these things we did for you because background work is really hard. Let us manage as much of the lifecycle as we can unless you have some sort of custom situation, and at that point you're already doing tons of research, so you're golden, right? Okay. So implementing Wakeful Broadcast Receiver, look, it's exactly the same, except I added the word wakeful. Like, it's not scary at all. It's the only change. I mean, I'm serious. Like, all these things, we worked really hard, finally, to like make these like great tools for you because it wasn't easy for so long. Okay, so I mentioned that GCM has its own special situation, and I'd like to explain a little bit more about that. We really try to push GCM, not just because we like love our own products, but because if you have to maintain a persistent network connection on a device, that's expensive. It drains radio, it drains CPU time, it drains the battery. And so if every app is trying to do their own homegrown version, that's going to be horrible. But if we can create one that the entire device knows about, that's like smart enough to know when to pass things along to the right apps and has the right access things, then we can save huge performance wins, huge user wins, and huge developer effort, right? And that's why you can see us, we're always pushing Google Cloud Messaging. The other thing is that GCM has an advantage that your homegrown version will never have, and that's that all of our carriers have worked with us to give like special recognition to the ports that GCM travels on to keep them open as long as possible, right? And so any messaging alternative that you'll see, your downstream messaging, will usually be built on top of GCM or will be built on like a polling system. And if you don't want to build your own polling system, why would you want to build on top of another one, right? So throughout the conference, as you see us all basically force feeding you GCM, know that we have a really good reason for it. It's not just because we happen to be cousins with it. Okay, so the other thing about GCM receiver is it actually extends from Wakeful Broadcast Receiver, so you get that wake lock management by default, which is even better. So to use it, you have to declare your receiver the way you would any other receiver, except you have to have something special, which is the permission to send. That means that you are basically adhering to the permission required by GCM because it will you want protected communication. So GCM service requires this permission, and you honor that permission, and that's what this lets you to do. So you to declare it in your manifest. And then also, you set up an intent filter to say, like, I want all receiving messages from GCM to my application, right? Super easy. Okay, so then you build your listener service. But do you notice you don't have to build a receiver? You don't have to extend from GCM receiver. Like, that already exists for you. You just have to use it by declaring it. And then all you have to do is override your listener service. It's not an intent service, but it's still pretty great because you don't have to manage any life cycles still. And then your message comes in with like who it's from, so you get your server ID. You can double check that like you're getting it from the right message in case maybe you have multiple different things. And you get all the information you need in data based on how you structure your own data when you send it, right? So great, so great. Why are you not doing this? Okay, so now we can move on from how background work specifically uses it, like goes like how to implement it, to when to implement it and how to invoke it, right? Like, you know that you can call start service, but the question is like, what do you really use to trigger a reminder when it comes later? And like when does it need to come later? So considering that question of when, if you need your work to run at a specific moment in time, you're going to get to meet the alarm manager. So an alarm is not like a wake up alarm, like ding, ding, ding. Alarm is a signal to your app that it's time for your app to wake up and do some more work. And when you register an intent with an alarm, it'll actually fire that intent as soon as it fires through the alarm manager. So setting alarms with alarm manager. To set a single alarm with anything that's above API 19, you can call set. Look how simple that is. And it sets a single inexact alarm. And what inexact means is that, let's say your alarm's supposed to go off like in an hour. It will not go off before that hour, but it may go off sometime after that hour if the system is trying to intelligently batch things together, right? Because we want to save battery as much as possible. So if we know that there are 4 alarms coming up sometime between 3 and 4, we might try to run them all at the same time. But it will never fire early, and that's a guarantee. We also have set window, which is if you're flexible and you don't really mind using set, but like you want to have a definite like duration of time, this is pretty great because you can specify what that window is going to be. And then for when it really does matter, we have set exact in order to specify that time actually really does matter. And this is important for maybe like a calendar reminder. If you're 40 minutes late on that, you've actually really messed up with your user's life. The other thing to note is that any API before 19, set and set exact are equivalent because we didn't actually introduce an exact timing until KitKat. So APIs before 19, you would just call set, and it's already exact. How great is that? Okay, so to do this, look how few lines of code this is. Like, this isn't terrifying. Like, you don't have to worry. You just get the alarm manager service from the system, create your intent, and you have to turn your intent into a pending intent, and that's how the alarm manager is able to actually fire it. Definitely use request codes here. So I'm skipping. You could call a receiver here. That would make a lot of sense because maybe you want to react to like a different kind of thing. I'm just skipping straight to the service. Like, I know that this alarm means it's time to run this thing. I'm just going to invoke that service directly, and then I set it up for whenever I want it to go. Time to trigger. I didn't declare that because I don't know while I'm here. Maybe I want it to be in an hour. Okay, different situation. Maybe you don't want a single alarm. Maybe you want an alarm that repeats itself on its own schedule. This is, surprisingly, still alarm manager. You're not surprised. It's not a surprise. Okay, so with repeating alarms, we have set inexact repeating for, guess what, inexact repeating alarms. So you specify a period of time, like maybe you need it to go off every hour, but not necessarily on the hour. You have a little bit of give there. So it will go off every hour, but maybe at 15, maybe not. Which is pretty fantastic as far as like, I need this to be done fairly regularly, but I don't specifically care that it's at 4:02 p.m. And then that means that you can talk about set exact repeating, except that doesn't exist. That's not a thing. We didn't create that because it doesn't make a whole lot of sense. We actually say use set exact to set a repeating alarm, and then when it triggers that one, set the next one. Because if it's that exact, you probably have something else you care about, and you probably want to check on that. The other truth is we actually don't really recommend this either. We'd rather you just not set exact repeating alarms at all. So set exact repeating is really your answer, but if you need a special use case, just do it one at a time and build that into how you manage your alarm. So to set an inexact repeating alarm, you see how it's pretty much exactly the same as far as setting it up, and then you call set inexact repeating, but instead of just saying the time to trigger, you have to add that interval that you really care about. Again, I just made up a variable because I don't specifically care about counting out milliseconds right now. Now, what if you need your alarm to go off often? Like, let's say every 60 seconds, right? Like, it's something that triggers another action. Maybe you're checking it on a sensor, or like there's something that you need to do incredibly, incredibly often. We don't recommend Alarm Manager at all. We think you should write your own handler to handle this kind of thing and use a time trigger. But I'm not going to teach you how to do that because that's really bad for performance and battery, and you should probably try to find an alternative instead. But you should know that it exists. Okay, now when your job needs to go off at some point today, maybe-ish, like just whenever we're on Wi-Fi, like either when you don't really care, you just want it to happen, or when you're waiting for a specific set of conditions to be met. This is when you're going to get to that wonderful thing that's called Job Scheduler, and you're not afraid, right? Because you have all this background, and you're like not intimidated anymore. Okay, so Job Scheduler isn't complicated. It's just got a lot of pieces to it. So let's talk about background. It was introduced in Lollipop, and what it does is it doesn't work off of a time schedule the way an alarm does. Instead, it works based off of conditions, like maybe I'm waiting for Wi-Fi when the user isn't actually using their phone. Like that's a pretty good time to run an upload of photos, right? Job Scheduler is designed to make it really easy for the system to batch jobs, because everybody says, I have this job, it needs to happen at this like kind of situation, and I have one too, and you're like, oh great, you both want Wi-Fi, Wi-Fi's on, let's go together. Like hold hands, you've got a buddy. And that's our battery and perf win, which will make Colt McCandless really happy. The other thing is Job Scheduler surprisingly runs on the main thread. And I'm not really kidding you, like the job service that you create will run on your main thread. So when you're actually doing complicated work, you use your job service in conjunction with some other background service, like a task, an async task, or like an intent service, right? Okay. So to use Job Scheduler, you start by creating that job service that runs on the main thread, which is very odd in my mind. To do this, you need to override at least 2 methods, if not more. The first is onStartJob, which is called not by you, but by the system when it's time to start your job. But because it runs on the main thread, this is the place where you want to kick off to your other work when you're doing heavy computations. If you're just setting a job to maybe send a notification because it's like 6 o'clock and it's a reminder, then that's fine. But like anything that's like heavy, you want to kick it off here. And when you override onStartJob, in addition to starting whatever work yours, you need to return a Boolean. So you're going to return true if you've moved work to a background thread in order to perform that kind of stuff, to show that something else is going on and the job scheduler needs to be aware of that. But you return false if it was a simple task and you've already finished and we're done processing. So that's what that Boolean means. And then for for onStopJob, you actually, this is called by the system again, but it's only if a job is canceled before it gets a chance to be finished. So maybe you were waiting for Wi-Fi and then you had it, but the user left the Wi-Fi zone and now you don't have it anymore, but you haven't finished. So we canceled the job because those conditions aren't being met anymore. And so this is what this Boolean's for. Whatever cleanup you need to do is important. But also you need to return true if you want to reschedule that job because it didn't have a chance to run. But if it didn't really matter, then you can return false and it will just be dropped. So that's what those super indicative Booleans are. And then that third method that you don't override but you need to call that lives inside of job service is job finished. And this is how you call it. You need to, in your service, like way away that you've kicked off to, once you're done with your work, you call this and you pass back the job parameters that were passed in, you see, from here, your onStopJob. So I included them in intent, but you need to pass those parameters back to indicate which job we're finished with. And this tells the system that we actually completed, like we're good. We're very, very happy and we're done and you don't have to worry about rescheduling. Unless you failed at your job. Maybe like the network connection fell through or something on your server's end. And so that's what that Boolean here means. So true means we need to reschedule the job, and false means that we're good. And when we're rescheduling, true will kick off Job Scheduler has a built-in exponential backoff for you. You don't have to do that math. You don't have to like track of like when you want to retry. Like we'll do that intelligently on your behalf. We just know that you didn't succeed and you want to try again, and so we'll reschedule you. Look how helpful we are. Okay, I like how I'm talking about it. Like I didn't work on this. I just know how to use it. You need to register your service as usual, but you also need to bind to the job service. And so yet another permission that's nested in with our declaration. And finally, you create the scheduler. So this is going to be probably in an activity, wherever you're keeping track of your thing. And there's a couple pieces here. So second bit of this is the job scheduler. We're just fetching that from the system again, very easy. And then we create a job info object. And that needs some sort of ID for the job so that your activity knows what's going on, but also the name of the service. So for the first time, we're not using an intent to rely on. We're just using the class name, which we get from the component name class. And then all of the conditions you care about, and I'll touch on that in just a minute. And then you just call scheduler schedule with your job info. Very, very easy. So the hard part is with job info, and these are like just some of the offerings that job info offers. So these, I told you you could decide you only care about certain criteria, and this is where you can set all of those criteria when you're worried about your job. Okay, so a couple of these are pretty obvious, like you can create your own back off and retry policy, and then that'll be used when we're rescheduling your job for you. You can create a minimum delay before your job is run. So if you say, like, I want to do this whenever whenever Wi-Fi's on, but I don't want to do it until at least 6 hours from now, like that can be really helpful, especially if you're managing traffic with your server. We have an override deadline, so that's the maximum amount of time that can pass before your job must be run. That's really helpful too, like if you know that you have to get something done today and it's going to hit midnight or whatever. Persistent indicates that you want to persist this job request across a reboot. A lot of times, like when your app is like started for the first time, then you might change your behavior. But if you know that you need this like after the reboot, then that'll be that's a great way to indicate it. Then we have connectivity requirements. It could be you're waiting for any network, metered or not, or maybe you're just waiting for Wi-Fi specifically. And so you've got some constants in the class that'll help you specify that. And then, of course, charging and or idle. Idle indicating that the screen is off, usually. OK, so this is the magic of Job Scheduler. This is like where it really happens. And then we have this hypothetical situation of, like, do I just use one? And I would say, no. So what if you have a situation where your user presses a share button that kicks off your intent service, because the share probably needs to happen right away. That's user initiated. But you're not actually online for some reason, like maybe it's a bad connection or maybe you can't really establish HTTP. So you could then use your intent service to schedule a job service for you, right? And then that way you don't have to worry, again, about keeping track of your own back off or your own retry. You don't have to worry about like what's going on. You can just be like, okay, I failed when I tried to do it immediately. The user probably won't notice since they're not on internet anyway, so let's just schedule this for later. And this is just one of those things where like it's hard to teach. Like how do you teach someone to consider multiple different resources to build the best possible behavior? This is one that like I was talking about my talk, and Ian was like, well, like you should tell them about like fun things. And I was like, I didn't even think of that. Like, how do I stand up here and teach people if I can't even think of all these things? And so it is hard, and that's why I really like when people share about this stuff, because like this would be a great situation, and it makes things so much easier for the developer. Like you can use these kinds of services not just to take work off the main thread, but also to make it so you don't have to build your own logic that's been built 17,000 times already. Okay, so try and teach you how to build better apps and also how to not work very hard. This is going to be really successful, you guys. The final point I want to touch on is what about actual alarms, like those ones that go ding, ding, ding and wake you up from your nap, right? If Alarm Manager manages the other alarms, like how do you actually schedule these? Like those seem really important. Like do I have to like issue my own sound notification or something every time my Alarm Manager goes off? And the thing is, no, you don't, because Alarm Manager has this super helpful set alarm clock method. And then, of course, you can get the next alarm clock. But that's introduced in 21, clearly, since I wrote that on the thing. So what's special about these methods is they were introduced relatively recently. And also, these are exempt from any kind of doze mode or app standby idle mode that we've introduced. Because alarm clocks are incredibly important, like the user probably relies on those for getting to work on time. And so what's really cool about these two methods, or not two, one's just to let you know when the next one is, but what's really cool about set alarm clock is that if you set that alarm, let's say for like 6:30 in the morning, and you're in doze mode because you forgot to charge your phone overnight or whatever, doze mode will exit well before 6:30 to give every app a chance to run and sync. So when the user finally hears that noise and wakes up and checks their phone, like everything's ready, like the news is already there. And so I think that that's a really cool build around. So you can definitely rely on these. If you're not quite to 21, but you're on KitKat, you can just call set exact. Because we're not worried about doze because you're on an older phone. But you know exactly that this time is going to happen because set exact will be honored. And then finally, for before KitKat, you can just use set directly because we didn't introduce an exact timing until after that. And so that's how you would cover actual important alarms. And that's my whole talk. Other things you probably want to look into are sync adapters, which will help you manage data programmatically on your own. And also we have GCM Networks Manager. So if you want to look at something similar to Job Scheduler but is a little bit more targeted, you should read that documentation. But hey, now you're all Job Scheduler pros, right? Like you could totally do this on your own, right? Right? That's not very enthusiastic. Thank you, Alex. Okay, cool. This is how you can find me on Google Plus and on Twitter. If you have any questions, always feel free to comment me. I will honestly try to respond to them. I'm bad at social networking, but I'm working on it. And I will be mingling in this room if you have any other questions about how to do this. But hopefully you're not scared of background jobs and services the way I was last year.